Okay, this is the study of population growth project. This will be considered a computer work assignment, which means I will send it back till it's right. So make sure you do it right the first time and make sure that I send you back with 100 so that way you know you did it right. All right, so on the following slide is a table for 10 different states. So if you look right here, here is 10 different states. Okay, now don't pick North Dakota because it's going to give you data that I don't want you to have to worry about messing with. So don't pick North Dakota. All right. Also, don't pick California because I'm going to do California with you, just for an example. So no North Dakota, no California, any of the other two states, it doesn't matter. All right. So once you pick your state, put what state it is right here. And then complete the table and create a scatter plot of the data on the grid provided. Code the years based on the number of years since 1900. Enter the data in lists on a graphing calculator, which we'll do in just a second. So as far as putting the data in, years since 1900, so 1900 would be 0, this would be 1910, 1920, and they've already pretty much got all this right here. So this is going to be your X value for both states that you do. All right, and then whichever state you pick, this is your Y value. So I'm going to pick California, so it's going to be my Y value on the first one. Okay, so first thing you need to do is open another tab, make a spreadsheet, make it blank, and then I would name this study of population growth, which I'm probably just going to add one to the assignment so you won't have to add the spreadsheet and name it. I'll probably name all this for you. So right here, you put all your X's, and right here, you put all your Y's. So give me just a second and I will type all that in. All right, so there is the data typed in right here, just like this. And just like the other problems that we've been doing in the past, you highlight the data, insert a chart, and since we still want a scatter chart, I'm going to change it to a scatter chart as soon as it pops up. So I go over here to line chart, change it to a scatter chart. And if you look, this one has a little curve in it. Okay, some of them have a little curve, some of them don't. If they don't have a curve, then it's linear. This one has a little curve, so it's probably exponential. And we'll check it in just a second, but it looks exponential, and the ones that are, you can just about tell. So now you go to customize right here, series, scroll down to where it says trend line, just like we've done in all the two assignments before this one. Only this one, instead of a linear trend line, I'm going to change it to exponential. And you see how it kind of curves along with the data just a little bit better. See, I can put it on linear and see how it doesn't quite match up as well as this one does. This matches up pretty well. It's a little off right in here, but it matches up fairly well. And then scroll down just a little further. And now, on the label, when we did the ones in the past, the label, we would use the equation. On this one, we don't want to use the equation because the exponential equation is not going to match up to the one that is easier for you to work with. Okay, so we can just leave it like that, and then you copy and paste it into the assignment right here, down here. So we copy and paste it down here. Let's see. Okay, so we paste it into here, and I'm going to link the spreadsheet. I do want you to link it this time. And then there it is. Okay, now, let's see. Now we need to put the data in the calculator. And let's see, code the years, enter the data on the graphing calculator. Actually, we're going to do that in just a minute. I want to show you on the next page, It says use the model to predict, actually, let's do the next one. Make an educated guess as to whether the data would best be represented by linear or exponential. This one, I would say exponential. Yours could be linear. There are some that are exponential and there's some that are linear. Based on your answer in part B, use the calculator to write the regression equation for the data. So here's where we're going to use our calculator. I'm going to pull it up, and then I'm going to type in the data just like we've been doing in the past. So stat, edit, and then I'm going to type in the numbers there. If you need to turn on your diagnostics, I'm going to go ahead and do that just to refresh everybody. Remember, it won't give you the R unless you turn your diagnostics on. And if your calculator is shut off, you may have to turn it back on. So diagnostics on. And now we're ready to do stat, edit, and then I'm going to type in all the data. All right, once all the data is typed in, this is your X's and this is your Y. And again, this is my California data, and then this is going to be your list one on both states. But this is my California data right here. Then I go to stat, calc. Now, when we did these in the past, I told you to use a linear regression. Mine is not linear. We decided that it was exponential. Now, I'm going to check it just to make sure. I'm going to go ahead and do linear, and I'm going to look at the R. Remember, if the R is closer to 1, then that's the one you want to use. This one says 0.973. Now I'm going to do stat, edit, calc again, only this time I'm going to do exponential, which is right here. Number 10. Hit enter, enter. And this one's 0.98. And as you can see, 0.98 is closer to 1 than 0.97. So it is exponential. Now, when I write my exponential equation, I'm going to put down here y equals, based on, write the regression equation, y equals A is 1903.2. So right here, I'd put y equals 1903.2 times, and I'm going to put that in parentheses, and then I'm going to pull this back up, and the B is 1.032. 1.032. Don't just put 1. Go to about 4 decimal places. If I go to 4 decimal places, this 8 makes this 9 go up, which makes it 0.2. So 1.032. So down here, I'll put 1.032, end your parentheses, and then it's to the, which is shift 6, x power. That is my regression equation. Okay, so on the next question, it says predict the 1950 population using your regression equation. So if yours was linear, you wouldn't have it looking like this. It would look y equals mx plus b, just like we did on the last 2 worksheets. All right, so on this one, predict the 1950 population using your regression equation. So 1950 would be 50. So what I would do is right here in place of x in my calculator, I would put 50. So I would go back to normal, and then I'd put 1903 times parentheses 1.032 in parentheses to the, and in this case, I would put 50th power because they want to know what it is in the year 1950. So if I hit enter, it says 9187.5. So 9187.5. Now it says predict the population, 1950 population using your regression equation. Is the predicted value above or below the original data? So we need to look at 1950. Right here, my original data was this number here because I was doing California. So 1950 was 10,586. So down here, it says, is it Is the predicted value above or below? My data is below. All right, so I would type in below. And then in AP statistics, the actual minus the predicted is called the residual. What is the residual? So I would take, what is this? 10,586. So 10,586 minus 9,187. 9,187.5. So I get 1,398.5. So I would put residual is, and I've already forgot the number, 1398.5. 1398.5. So explain the meaning of either a positive or negative residual in the context of the situation. All right, so in this one, it's if the residual is positive, then that just means that my predicted value is lower. So that's why I would write residual is positive. So the predicted value, because this is your prediction, the predicted value is less than the actual. All right, explain the meaning of that's what we just did. It's positive, so the predicted value is less than the actual. If the value of the residual is 0, what does this mean? Well, if I subtracted those two numbers and I got 0, doesn't that mean that the actual and the predicted value have to be exactly the same? So if they're exactly the same, then your residual is 0. So that means the actual minus the predicted is the same. So that's what you'd write. So then we go down to the next one. Use the model to predict the year for the predict the population in 2010. Provide reasons why the model is or is not reasonable prediction. So 2010, that is 110 years past 1900. And I put my number in the calculator wrong here on this last one. Should have put 1903. Parentheses 1.032. What just happened? 1903 times 1.032 to the 50th power. So I should have gotten 9,192 right here. So 1,192. Which would have changed my residual a little bit, and so on. Okay? So just make sure you put the stuff in the calculator right. I did not put the right number right there. All right, so if the value of the residual is 0, we already did that one. Predict 2010. So in my calculator, 2010, I'd still put 1903 times parentheses 1.032 in parentheses to the 2010 would be the 110th power. So I put 60,842. So 60,842. Now the next one, and then it says, would you trust the model's year for the prediction of 3,000? So first off, this is 60,302. And in the year 2000, I had 33,000. So it doubled in that 10-year period. Is that something that could happen? I mean, I guess it could. So it says provide why the model is not a reasonable solution, because it says the population doubled in 1 year. Would you trust it's for the year 3000? So if I put the year 3000 in there, that means I would be putting, what's 3000 minus 1900 is 1100. So in my calculator here, this exponent would be 1100. 1903 times 1.032 to the 1100 power. So this number is so big, it's got this e to the 18th power. E to the 18 over here just means, that's like scientific notation. That means you move the decimal place 18 spaces. So we're talking about a number that is just really, really big, bigger than a trillion. And we're talking about a trillion thousand. So a lot. So do I think that that's what's going to happen? I think it's going to be too big. Why? Because it's growing. This one's really growing exponentially. All right. And then examine the shape of the data and determine if unusual variations in population occur. So if we looked at our scatter plot that we made, it looks like right after 1950, it really started to shoot up. Well, what happened in 1950? It was right after World War II, and that's when the baby boomers happened. So, all right, so that is pretty much what you would do you'd answer all these questions for your one state, and now you're going to go do your next state. So you do all of it again, just for a different state. Besides, you can't pick California and North Dakota still. And then if you picked one of these, pick another one. And then do it all again. Put your stuff in the spreadsheet. Now, when you're making your spreadsheet over here on this page, all you got to do is down here. I don't know if I can move this out of the way. My cursor. I want to move this. Right here on the bottom of your spreadsheet, there's a plus sign, and I don't know how to move this little tool. Anyway, right in here, let's see if it, right in here, that's not what I want to do. Anyway, right in here, there's a plus sign on the spreadsheet, and when you click it, it will add just another sheet to this spreadsheet, and then you put your number 2 on this right here, and then you can link it and do it exactly the same way you did this one, and then turn in the one spreadsheet that actually has both scatter plots on it. And then go back, and then don't forget to answer all the questions for the second state, just like we answered all the questions for the first state. It's the exact same questions, just answer them again. Remember, you put 110 in place of X, you put 1,100 in place of X on this one. Your equation may be a little different because it might be Y equals MX plus B, or it could look like my equation that I just got through doing. Okay, so if there's any questions, let me know.